Okay, so I had this moral dilemma about teaching this. Let me make sure. Okay, and here's the thing that, Tori, put it away. Because of the invention of Desmos, I'm shocked because of Desmos, we can do this on Desmos. And actually, this is a skill that is really difficult for some kids. And the major thing that you have to know about factoring is you got to know your times tables. And what stumps people is they don't know their times tables, and so you can't do it. We'll talk about that later. Also, you have to know your multiplication of integer rules and your adding, subtracting of integer rules. And so what we were talking about earlier, Megan, about same signs, positive, different signs, negative, you have to know that's the multiplication rule. And you have to know same signs add, different signs subtract, that the adding and subtracting of integer rule. Okay, and then you also have to know what's the sign of your answer when you add and subtract. It's the sign of the biggest number. So all of those things come into play in order to factor. Now, one thing that if I did cheat and do this on Desmos, one thing that you would need to do is Desmos does not do this. See this right here, this very first page? Desmos will not tell you the greatest common factor. So that's where kids, they're doing it on Desmos. They're getting part of the answer, but the other part is knowing if there's a greatest common factor. Okay, and so that's how they're kind of getting around the Desmos thing. All right, so Tori, sit up. Honestly, this is hard. If you don't pay attention, you will not get it. Okay, so you need to make sure you're paying attention. This is new, and I struggled with this when I was growing up. Okay, so before, remember we were doing the box method to multiply, and then we got this answer. Okay, so it was kind of a way to distribute. Well, what we're doing right now is we're going to do something called undistributing. So this is an answer right here that has been distributed. We've distributed we've multiplied two factors, and we got this answer. So now we're going to work backwards, and we're going to undistribute. So we're going to look at these two numbers, 3 and 12, and see if there's anything inside of those that we can divide by. So you know the homework that we just went over? So remember how we can just break it apart like that? Well, 3 is the greatest common factor of 3x and 12. So I can divide both of these numbers by 3. Okay, and this is, think about what our problem looked like a couple days ago. It was the greatest common factor times, and now I'm going to work this out. What's 3x divided by 3? We just get x. And what's 12 divided by 3?
What's that? What's that?
This. Okay, this is the answer. Okay, because if you think about it, watch. 3, if I distributed this, I would get 3 times x, which is 3x. 3 times 4, which is 12. Okay, this right here is what I got when I divided by taking out that 3. Okay, does that make sense? Okay, so let's try number 2. So look at those two numbers. What can I take out of both 7y and 7? Can take out a 7. Okay, so like our homework, we're going to divide both of those by 7. That 7 that I'm dividing by is the greatest common factor. That's the GCF. So now I'm going to ask myself, those cancel out. What do I have left? Y. And what's 7 divided by 7? So we have a -1. So how do we write our answer? The greatest common factor times y minus 1. Okay, now this is extremely important. That's in the parentheses is a factor. This 7 is a factor. That means if I were to distribute or multiply, I would get this answer right there. Travis, hands off the keyboard. Okay, so now we're on number 3. And if you look at that problem, here's the hard part. And again, this is why factoring is difficult for people, is I have to decide the biggest number that goes into 8 and the biggest number that goes into 36. So everybody open up Desmos. Pull up Desmos, please. And this is a game changer. All right, we're going to make a table, just like we did before. Okay, and this time when I back out of my y, I'm going to do 8 divide x1. And I'm going to have a new column, and I'm going to do 36 divide x1. All right, now let's do our 1, enter 2, enter 3, 4, 5, 6, 7. Okay, so here's what you have to do now. Let me make this big. So I'm looking at my division chart that I just made. Okay, so forget the graphing part. And if I wanted to, I went to the number 8, but I could technically go to 36. That's our biggest factor, but it doesn't matter. All right, so I'm looking for a number that's in the 8 column and the 36 column, and that are the same. And I have to find the biggest number. So this is what I'm going to do. Go to the 8 column. Do you see the number 8 on the 36 column? Look, I have 36, 18, 12, 9. Do you see the number 8? No. All right, how about 4? Yep. Okay, I see a 4. All right. How about a 2? I see, well, there's going to be a 2, but I don't see it yet. Okay, but the biggest number that is in both of these columns is that number 4. So that's my greatest common factor. My greatest common factor is 4. So go back, and we're going to divide both of these by 4. And 4 is the greatest common factor. Okay, Tori, what's 8 divided by 4? 2. And I have an M. And what's 36 divided by 4? And I have an N. So this stuff goes on the inside, 2M plus 9N. And if I wanted to check my answer, I could distribute, and I do this, Landon, stop. I do this in my head. So 4 times 2 is 8. All right, there's an 8. 4 times 9, 36. Okay. Then another thing that I recommend that you do is check inside your parentheses. Is there anything that can be broken apart in 2 and 9? What I mean by that, is there anything that divides into both 2 and 9? No, nothing. Okay, now let's try number 4. Does anybody know what I can divide 5 and 30 by? 5. Okay, so divide them both by 5. So I'm pulling out a 5, and what's left over? An x plus 6y. 30 divided by 5. So my answer is 5 times x plus 6y. Now, eventually, this is what's going to happen in Desmos. When I type these factoring problems in Desmos, I'm going to be able to get one of the answers, this in parentheses, but it will not tell me the 5. So that's why we always, first thing when we factor is see if the problem has a greatest common factor. Okay, turn the page. All right, and we are going to do number 6. Okay, we are doing number 6. So what can I take out of a 4 and a 24? All right, divide by 4. Is there anything else I could take out of a y squared and a y? So this y squared is a y and a y, and this is a y. If I'm playing cards, can I take out a y in both of these? Yeah, so actually the greatest common factor in this one is 4y. Because they each have a y. Okay, and so I'm going to write what I took out, and now I'm going to work it out. So 4 divided by 4 is 1. Y, we subtract the exponents. And 24 divided by 4 is 6, and those y's cancel out. So I have y minus 6. All right, let's do number 8. What can go into 14 and 8? And notice I don't worry about the negative, and I really don't know. So I'm going to type in 14 and then 8. 18, thank you guys. All right. So do you guys see a 14 on the 18 column? No. A 7? No. No decimals. A 2? Yep. So that's my greatest common factor, 2. All right, divide them both by 2. Can I take out a letter? What? H. Good job. Huh? They're going to cross out, but they both have H's in them. See, this one has an H and that one has an H. So that means I can take away an H from both of them. Okay, so number 6, this one had 2 Y's. This one had 1 Y, so I can only take out 1, right? Okay, so that's why I took out a Y on both of those. Okay, so now I took out a 2H. That's my greatest common factor. And now what's left over? I have a 7G minus 9. 7G minus 9. Okay, does anybody have a question? Okay, let's skip down. We're going to do number 15. Going to number 15. So what can I take out of a 2, and a 4? Let me tell you one thing though. It can't be bigger than any of the numbers. So we couldn't say 4 because 4 is bigger than those 2's, but I can take out a 2. Anything else?
An X and a 1.
Okay, how many X's? Well, that has 2, that has 1, that has 1. So I can only take out one of the X's and only one Y. So take out a Y. Okay, and since this one's long, I'm going to write 2XY. And what do I get when I work out the first term?
X,
Okay, what about the second term?
Y, minus 1, and then plus 2.
Yeah, good job. What, Landon?
That would not make sense.
What part, sweet pea?
Like, how would you do the other one?
So see this X squared right here? That means I have 2 of them, right? And I have 1 here and I have 1 here. Do they have any X's in common? How many? Yeah, see, I can only take out 1 because I can't take out 2 because does this guy have 2 to give away? Nope, nope. So that's why I took out an X. Now let's look at the Y's. So I have a Y, and a Y. So what's the most number of Y's that I can take out? 1. So that's why I took out a Y from everybody. Okay, so it's kind of like looking at the leftover. See, that first term has a leftover X. That's why we put
There
that.
should be more than one Y you take out.
Yes, sometimes if it was like the exponents were a 3 and a 5, then I could take out 3 of them. Yep. Yeah. Yes, yes, yes. Does that make sense, Landon? All right, well, let's do another one. Huh? Yeah. Let's do number 18. So I need to know what goes into 12, 36, or 6. 6. Okay, remember, if you didn't know that, you could type it in Desmos and use the chart. Okay, and by the way, I could add another column. So right now I have 2 columns, but I could do 12, 36, and then I would just make another column, 6 divide x1, and then see what they all had in common, which is 6. All right, so back to this. So number 18, we're dividing by 6. Now, Landon, can I take out any letters? Okay, here's the trick. Okay, so Landon, check out your A's. This one has 5. Just listen, this one has 5. This has 4. This has 2. I'm gonna pick the smallest exponent. Which one is the smallest? 5, 4, or 2? So that's how many I can take out. Does each of these have 8 A's?
No, but all of them together are 8.
But it's not all together. It's like you're playing cards, Brady's playing cards, and I'm playing cards. Okay, and if it's my turn and I said, give me all your A's, you can't give me 5 A's if you only got 2, right? So you're gonna pick the lowest exponent. So then, Landon, tell me how many B's can I take out? Huh? What's the most B's I can take out? So let's check out our exponents. How many is that?
2.
Okay, what's the most I can take away? So this guy has 2, this guy has 3, and this guy has 2. And if I say, give me all your B's, how many can this guy give me?
1.
Well, no, he can give me 2 because this guy has 2 also, right?
Yeah.
So we find the smallest exponent, which is a 2, and that's how many we're going to take away. Whichever one has the smallest exponent. All right, and now we're going to divide. Okay, and don't forget, and sometimes I forget to do this, write my greatest common factor, because that's still part of the answer. So what's 12 divided by 6? Subtract our exponents, 5 minus 2. What's 5 minus 2? And what happens to the B's, Tori? B squared over B squared. Okay, and what's 36 divided by 6? Okay, how many A's would I have, Landon?
2.
B's?
1.
Okay, now what about my last term? Cancel, cancel, 6 divided by 6 is 1. Now, honestly, on the SOL test, all of these problems at the end, they're not going to be that difficult. Okay, not going to be that difficult at all. All right, turn the page. Okay, so on this paper, we are doing 1 through 20. Okay, so we're just doing 1 through 20, and you have almost 30 minutes to do it. We are doing problems 1 through 20.